In this video, you will explore how to model numerical outcomes using linear regression, one of the most popular approaches in regression analysis. Let's get started. An overarching goal of regression analysis is to model numerical outcomes based on available input features. In linear regression, you model the target variable y as a linear combination of input features x. With one input feature, the model describes a regression line. With multiple input features, it describes a regression hyperplane. Here's an example of a linear regression model. The slope and intercept of the line are controlled by the regression coefficients a1 and a0, respectively. Fitting a linear regression model means adjusting these coefficients to best describe the relationship between x and y. To find the best regression coefficients, you calculate the error between the observed data and the linear regression model at each data point, referred as residuals. The best model minimizes the residuals for all data points simultaneously. The linear regression learner node in KNIME estimates this model. The learner node takes a data set in the input port and produces the regression model at the output port. In the configuration window, specify the target column, outcome variable, and the input features. For example, we'll use a car dataset to predict miles per gallon, MPG, based on the numerical feature horsepower, HP. After training the model, in the output table, you can examine the regression coefficients, their standard error, t-statistic value, and p-value. The model trained in the learner node can be used in the regression predictor node. This node takes a trained model and a dataset and produces predicted outcomes in the output dataset. The performance of the model can be summarized by various goodness of fit metrics calculated in a numeric score node. In the configuration window, you specify the target as the reference column and the predicted outcome as the predicted column. In this example, your model has an R-squared value of 0.588, indicating that the 59% of the variability was explained by this linear regression model. In this video, we've covered the basics of linear regression in KNIME. You've learned how to set up the learner node, configure input features, handle missing values, and evaluate the model's performance.